Hello, looking at our next unit conversion lesson, we're looking at converting compound units. So our usual plan or agenda for the day, our curricular outcome, apply proportional reasoning to problems that involve conversion between SI and imperial units of measure. So converting linear units. To convert linear units, proportionality ratios are used. Each ratio must equal 1, with one set of units in the numerator and another in the denominator. In linear units, we always put the units we want in the numerator and the units we have in the denominator. That is because the value we are trying to convert is in the numerator. With compound units, these compound units are made of more than one unit. Examples include speed, kilometers per hour, force, kilogram meters per second squared, and pressure. 1 Pascal is 1 kilogram per meter second squared. If the units we want to get rid of are in the denominator, we must cancel them with a ratio that puts the same units in the numerator. So let's look at examples. Let's convert 25 meters per second into kilometers per hour. So we start with 25 meters per second. 1 kilometer per 1,000 meters will take our meters in the numerator and turn them into kilometers. Now we need to get rid of the seconds which are in the denominator. So for turning seconds into hours, we need a fraction that has seconds in the numerator and either hours or an intermediate unit like minutes in the denominator. So if we multiply by 60 seconds per minute, we'll cancel the seconds, turn this into kilometers per minute. We need kilometers per hour. So we put another 60 minutes per hour in. Now we've canceled our minutes, we've canceled our seconds, we've canceled our meters. We're just left with kilometers and hours. So 25 meters per second is 90 kilometers per hour. Now, converting 30 meters squared into centimeters squared. Yes, this is a compound unit because we have 2 meters, not just 1. So we have 30 meters squared. Multiplying by 100 centimeters over a meter cancels one of the meters. We've got 2. We need that factor again. So to convert meters squared to centimeters squared, we don't multiply by 100, we multiply by 100 squared. We end up with 300,000 centimeters squared. Similar approach here. We're converting 14 centimeters cubed into meters cubed. To go from centimeters to meters, we divide by 100. Here we're going to have to divide by 100 cubed. So our first factor gets a centimeters squared times meter. Now we're at centimeters times meters squared. Now we're at meters cubed. So we have 0.0000014 cubic meters. We've taken our 14 divided by 1,000,000. All right, time for you to practice. If 1 milliliter is defined as a cubic centimeter, convert 1 cubic meter into liters. So we have to remember 1,000 milliliters make up 1 liter. We'll have to convert our cubic meters into cubic centimeters. Turn our cubic centimeters into milliliters. They're equal, so that part is easy. And then our milliliters back into liters. Few steps here. I just outlined them again. Convert cubic meters into cubic centimeters to milliliters, milliliters to liters. Pause now, take any time you need. All right, moving forward from here. We take 3 of our 100 centimeters per meter to convert cubic meters into cubic centimeters. Cubic centimeters, we have 1,000,000 of those. That's 1,000,000 milliliters, or 1,000 liters when we divide by 1,000. So 1 cubic meter is 1,000 liters. You ever wonder why your parents complain about how much it costs to fill the backyard swimming pool, even if it's a little plastic one? Well, that's why. All right, convert 100 kilometers an hour into meters per second. One of our examples did meters per second into kilometers per hour, so we should be able to do it with the same conversion factors. We just reciprocate them. Pause now, take the time you need. All right, so turning kilometers into meters is multiplying by 1,000 meters per kilometer. And then 1 hour per 60 minutes, 1 minute per 60 seconds is 27.7 repeating meters per second. Now, all this said, enough practice, some people will recognize that we just have 3,600 seconds per hour, and they work with that, turning 2 conversion factors into 1. How you want to do it is up to you. Exercise 3. A paint can label says it contains enough paint to cover 100 square feet. If a wall measures 18 meters by 6.5 meters, how many cans of paint will be needed? Assuming that the paint is as thick as the paint maker assumed. So we're going to have to calculate the square meters, turn those into square feet, remembering our conversion between metric and imperial is always 2.54 centimeters is 1 inch. Pause now to finish the job. Take whatever time you need. All right, so we multiply our 2 numbers together to get 117 square meters. Converting the square meters to feet, we multiply by the centimeters per meter, 100 centimeters per meter, we square it. Then 1 inch over 2.54 centimeters, square that. Multiply all that through. We get 1,259 square feet on this wall. If it's 100 square feet per can, then it works out to 12.593775. You follow this long enough, it will repeat because it's still a rational number. But that means we're going to need at least 13 cans. So if you do this without spilling, you'll do 13 cans, and that last one will have a little less than half of the can left. If it came out to 12.1, we would still round up to 13, otherwise you'd end up a little bit short. In summary, compound units can be converted by using multiple proportionality ratios. The goal is always to use ratios equal to 1, which cancel unwanted units, leaving only the desired units. If you have any questions or any feedback, please leave them in the comments. I will do my best to respond in a timely manner. Next up, we're going to start looking at some surface area and volume content.